Okay, so get this. We're going to deep dive into quantum physics.
Oh, wow.
And time travel.
Cool.
You know, I was checking out the stuff you sent me.
Right, yeah.
YouTube videos. One's from Strange Space.
Right.
And then there's one from Unveiled. And then there's that book, Time Travel, Religion, and Simulation Theory.
Yes.
And you're really fascinated by,
Yeah.
is time travel possible? Especially with everything we're finding out about quantum physics.
Right.
So we're going to, untangle some of the science, look at the theories, and figure out what's real and what's still fiction and what's, kind of in between.
Yeah, for sure.
Yeah.
One of the interesting things about this whole topic is that time travel may not be as far-fetched as it sounds.
Really?
We may already have a very limited form of time travel that's already happened.
Wait, are you serious?
Yeah, I mean, if you think about
so many questions.
Yeah. Tell me more.
Well, Einstein's theory of relativity.
Completely revolutionized our understanding of time.
Okay.
It's not this rigid, unchanging thing.
Right.
It's actually influenced by gravity and speed. Okay?
Okay.
So think of it this way.
Yeah.
Imagine time as like a flowing river.
Okay.
And then a massive object like a planet or a star would actually warp the flow of that river.
Whoa.
So it would make it speed up or slow down depending on how close you are to it.
Okay, so time is more like this fluid dynamic thing.
Yes.
And gravity can actually warp it. That's so cool.
Yeah.
So what about speed? How does that play into that?
Think of it this way. The faster you move, the slower time flows for you.
Okay.
Relative to somebody who's standing still.
Okay.
And they have unveiled a great example.
Yeah.
They talk about this Russian cosmonaut, Gennady Padalka.
Okay.
He holds the record for the most time spent in orbit.
Wow.
And because of this extended time in space, where the gravity is weaker and he's traveling at super high speeds, he's technically time traveled a fraction of a second into the future.
No way.
He's actually a tiny bit younger than he would be.
Wow.
If he had stayed on Earth.
That's wild.
Yeah.
So just by being in space, he's experienced time differently than we have here.
Right.
I never thought about that before.
Yeah.
But I have to ask,
Yeah.
A fraction of a second, that doesn't really sound like a very exciting time travel adventure.
Yeah.
So what about traveling years or decades or centuries into the past?
Yeah.
Is that even remotely possible?
Yeah. And that's where quantum physics comes in.
Okay.
It challenges this notion of time as this neat linear progression.
Okay, I'm ready to have my mind blown. Give me the quantum details.
Right. So in the quantum realm,
Yeah.
things get really, really weird.
Yeah.
You know, we're talking about a world where particles don't follow the same rules
Right.
as, you know, everyday objects.
Okay.
Like you can have a tiny particle that is in multiple places at the same time, you know, and it can exist as both a wave and a particle simultaneously.
Yeah.
So all that certainty that we're used to in our everyday lives kind of dissolves.
Okay.
And we're left with probabilities and possibilities.
Okay. So instead of a straight line, time in the quantum world is more like a tangled web or something?
That's a great way to put it. Yeah.
Yeah. Does that mean that we could somehow manipulate those probabilities to travel through time?
That's a great question. And it's something that scientists are still grappling with.
Yeah.
But, you know, there are some very bizarre quantum phenomena that suggests that time might not be as straightforward as we think.
Okay.
One example is quantum tunneling.
Okay.
And they highlight this in the Strange Space video. Imagine a particle suddenly passing through a barrier that it shouldn't be able to cross.
Okay.
As if it just tunneled through a solid wall.
What?
It's like it's borrowing energy from the future to make the jump.
Okay.
And it defies the laws of classical physics.
So these particles can basically teleport through walls. Does that mean that we could eventually tunnel through time as well?
Not quite that simple.
Okay.
Tunneling usually applies to particles at incredibly small scales.
Right.
To apply it to something as large and complex as a human would involve an insane amount of energy.
Yeah.
Like way more than we can currently comprehend, let alone harness.
Right.
But the fact that it happens at all on a quantum level is pretty mind-blowing.
Totally mind-blowing. It makes you wonder, what other strange things are happening that we just haven't discovered yet.
Yeah, exactly.
So what other quantum weirdness can you tell me about?
Well, there's these things called delayed choice experiments.
Okay.
And these are the ones that really make you question cause and effect.
Okay.
So picture this. You have a particle that's shot at a barrier with two slits. And here's the crazy part. The decision of whether to measure which slit the particle goes through isn't made until after the particle has already passed through the slits.
Wait, you're telling me that we're making a decision about observing something that has already happened?
Yeah.
How is that possible?
It's like the future is influencing the past.
Whoa.
Yeah, the results of these experiments suggest that our choice to observe the particle in the present somehow affects its behavior in the past.
Okay.
Even though the particle's already gone through the slits.
So it's like the particle knows whether we're going to watch it or not before we even decide.
It's incredibly strange.
That's so strange.
Yeah, and it definitely challenges our everyday understanding of time.
Yeah, are we saying that the future can literally change the past?
Not necessarily. Think of it more as like a subtle connection between past, present, and future in the quantum realm.
Okay.
Delayed choice experiments show that at the quantum level, things are way more interconnected than we realize.
Okay.
And that our actions in the present can affect how we perceive the past.
Right.
But it's not about literally rewriting history like Back to the Future.
Right.
And they emphasize that in the Strange Space video.
Yeah.
It's more about this deep connection between the observer and the observed in the quantum world.
That makes a little more sense.
Yeah.
But it's still pretty wild to think about.
Yeah.
And there's even more, right?
Yeah.
What about that quantum erasure thing you mentioned?
Yeah.
Tell me about that.
Okay, so imagine the double slit experiment again. But this time, after the particle hits the detector, we erase the information about which slit it went through.
Okay, so we're like wiping the particle's memory.
Yeah, it's like making the particle forget which path it took.
And does that actually change anything?
Yeah, it's crazy, but it does.
Really?
By erasing this which path information, the particle starts acting as if it went through both slits simultaneously.
Wow.
It's like the particle, in a way, travels back in time.
Okay.
And changes its behavior based on what we do in the present.
So it's like time is flowing backwards on a quantum level.
Yeah.
So does this mean we can actually rewrite the past?
Yeah.
Or send information back in time?
It's not quite that straightforward again.
Okay.
You know, these quantum phenomena, they highlight this bizarre nature of time and measurement in the quantum realm.
Yeah.
But they don't necessarily mean that we can build a time machine.
I see. So it's more about understanding the nature of time than actually manipulating it for time travel.
Right.
That's pretty deep stuff.
It is.
Yeah.
And are you ready to delve into some of the more mind-boggling theories?
Absolutely.
That try to explain these quantum phenomena?
I'm totally hooked. Take me deeper down the quantum rabbit hole.
All right, let's go.
So we talked about some pretty wild quantum phenomena that suggest time might not be as straightforward as we think it is. What are some of the theories out there that try to explain this stuff?
Well, one intriguing idea is retrocausality.
Retrocausality?
Yeah.
What is that?
So it's this concept that future events can influence the past.
Okay.
And the Strange Space video dives into this idea.
Yeah.
And they highlight how some quantum experiments suggest that actions that we take in the present can seem to affect the state of particles in the past.
So are we talking about like actually changing the past?
Well,
like going back and preventing something from happening?
Yeah, it's not about changing the past
Okay.
in a literal Back to the Future kind of way.
Okay.
It's more about a subtle influence that ripples across time.
Okay.
And you know the Strange Space video?
Yeah.
They use this analogy of entangled photons.
Okay.
So you imagine two particles that are linked together in a way that lets them communicate instantaneously.
Okay.
Regardless of the distance between them.
Wow.
And when you measure the properties of one of these entangled particles in the present, it seems to determine the properties that its partner had in the past.
Okay, so it's like these particles are coordinating their properties across time, even though from our perspective, one event seems to happen before the other.
Right, exactly.
That's fascinating.
Yeah.
But I'm still a little fuzzy on like, how does this connect to time travel?
Well, think back to that delayed choice quantum eraser experiment.
Okay, yeah.
We were talking about.
The one where we like wipe the particle's memory?
Right, exactly. Remember how erasing the information about a particle's path after it hit the detector made it act like it went through both slits?
Yeah, that was crazy.
Yeah. So some physicists interpret this as a case of retrocausality.
Okay.
They argue that our decision to erase the information in the future is what influences the particle's behavior in the past.
So our actions in the future can ripple backwards in time.
Right.
And affect what happened in the past.
Yeah, in a way, it's like...
Does that mean we can, like, send messages back in time or something?
I mean, while retrocausality opens up these fascinating questions about the nature of time and cause and effect, it doesn't necessarily provide, like, a clear path to building a time machine. But there are other theories out there that tackle the idea of time travel a little more directly.
I'm all for exploring those. What else is out there?
Let's talk about closed time-like curves.
Closed time-like curves.
Or CTCs.
The CTCs.
Yeah, and this idea comes from Einstein's theory of general relativity. So imagine space-time being warped so intensely that it loops back on itself, creating a path that leads back to a point in the past.
So I'm picturing like a cosmic roller coaster ride through time.
Right, exactly.
But wouldn't that create paradoxes?
That is.
Like, what if you go back in time and accidentally prevent your own birth or something?
You hit on one of the biggest challenges with this whole concept of CTCs is this potential for paradoxes that seem to violate the rules of cause and effect. But there might be ways around these paradoxes. Some theoretical models suggest that quantum mechanics could play a role in stabilizing CTCs and preventing those inconsistencies.
So quantum mechanics might be able to help us
potentially
avoid those time travel paradoxes. I'm curious, how does that work?
Well, this Strange Space video mentions something called the Deutsch model.
The Deutsch model.
And it proposes that quantum systems within a CTC could avoid those classic paradoxes by following probabilistic rules instead of the deterministic rules that we're used to in the everyday world. It's like saying that within a CTC, events unfold in a way that ensures consistency, even if it seems counterintuitive from our linear perspective of time.
So even if we could, like, figure out how to create a closed time-like curve, we wouldn't necessarily end up erasing ourselves from existence by stepping on a butterfly in the past.
Well, according to the Deutsch model, the inherent nature of quantum mechanics might prevent those kinds of paradoxes from happening.
That's good to know.
But of course, this is all highly theoretical. We are a long way from having the technology to even attempt creating a CTC. It would require something called exotic matter.
Exotic matter.
Yeah, which has this property called negative energy density.
Negative energy density? That sounds like something straight out of science fiction.
Yeah, it's a hypothetical concept.
Does it even exist?
You know, some quantum experiments hint that it might be possible. However, harnessing it on a scale needed to warp space-time into a closed time-like curve is beyond our current technological capabilities.
So while hopping in a time machine and visiting the dinosaurs it might still be in the realm of fantasy, it's not entirely ruled out by physics.
Exactly.
That's pretty exciting.
And who knows what the future holds as we continue to explore these mysteries of quantum mechanics and gravity. We might uncover possibilities we haven't even imagined yet.
Speaking of mind-blowing possibilities, the Unveiled video threw another concept into the mix. Wormholes. Like these theoretical tunnels through space-time, and they might be connected to quantum entanglement.
You're referring to the ER-EPR conjecture.
The ER-EPR conjecture.
And it proposes this mind-boggling link between wormholes, which is a concept from general relativity and entangled particles, which is a key feature of quantum mechanics. And it's still a topic of debate among physicists, but it's a very intriguing idea.
Hold on. I need a minute to process this. So you're saying that these entangled particles, which are already acting spooky by seemingly communicating instantaneously across vast distances, might actually be creating tiny tunnels through space-time.
That's the essence of the ER-EPR conjecture.
Wow.
If it turns out to be true, it would mean that wormholes and entanglement aren't separate phenomena, but two sides of the same coin.
Wow.
And it would revolutionize our understanding of the universe and its interconnectedness.
Now we're talking serious sci-fi stuff.
I know, right?
Could we potentially use these wormholes for time travel?
Yeah, and the unveiled video explores that possibility.
Okay.
But it also acknowledges the immense challenges involved.
Okay.
Wormholes, like closed time-like curves, are thought to be incredibly unstable.
Right.
Keeping them open long enough for something to travel through would likely require exotic matter.
Oh, that exotic matter again.
That same stuff with negative energy density.
Yeah, right.
And even if we could create a stable wormhole, navigating it to a specific point in space-time, it would be a whole other challenge.
Right. I can't just show up in ancient Rome without knowing the exact coordinates in both space and time. And we have to consider those paradoxes, like accidentally changing history by stepping on a Roman senator's toga.
Exactly. Time travel, even if theoretically possible, would raise a whole host of ethical and logistical challenges.
Right.
But, the fact that we're even having these conversations shows how far our understanding of the universe has come.
That's true.
Yeah.
So what would a quantum time machine even look like? Assuming we could overcome all these challenges. Right. Would it be like a sleek, futuristic spaceship?
It's hard to say for sure.
Yeah.
But unveiled suggests that a quantum time machine might involve manipulating entanglement on a massive scale.
Wow.
Like imagine creating a network of entangled particles that spans vast distances, maybe even across time itself.
So we're like weaving a quantum tapestry through space-time, creating a pathway for time travel.
Yeah, that's a great way to put it.
That's an amazing concept.
It is, isn't it?
Yeah.
Of course, we are a long way from having the technology to do anything like that.
Right.
But the fact that we're even starting to think about these possibilities is a testament to the power of human imagination. And our insatiable curiosity.
Okay. Before we wrap up this discussion, I have to ask about one more mind-blowing idea.
Okay.
The Strange Space video mentioned the many worlds interpretation.
Right.
Can you remind me what that's all about?
Yes, the many worlds interpretation.
Yeah.
It is one of the most mind-bending interpretations of quantum mechanics. It suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes.
Wow.
Each representing a different possible outcome.
So you're saying there's a universe out there where I won the lottery last week.
Precisely. And in another universe, you might have chosen a different career path.
Right.
Leading to a completely different life.
Wow.
The possibilities are literally endless.
That's both exciting and a little scary.
It is.
But how does the many worlds interpretation relate to time travel?
Well, if the many worlds interpretation is correct, it would mean that time travel wouldn't involve changing your own past, but rather traveling to a parallel universe where a different set of events played out. No paradoxes.
Right.
Because you're not actually altering your own timeline.
So instead of rewriting history, time travel would be more about exploring a vast multiverse of possibilities.
Exactly.
That's a really incredible concept.
It certainly is. It pushes the boundaries of our understanding of time reality and the nature of the universe itself.
Okay, let's shift gears for a moment.
Okay.
And talk about some of the more down-to-earth aspects of time travel.
Yeah.
The unveiled video mentioned some pretty intriguing stories.
And alleged evidence of time travel throughout history.
Right. Yeah.
Did any of those particularly capture your attention?
I'm always fascinated by anecdotal accounts of time travel.
Yeah.
Even though they generally lack scientific evidence.
Right.
The video mentions Stephen Hawking's time traveler party.
Oh, yeah.
Which was a fun thought experiment.
Yeah.
He sent out invitations to a party after it had already happened. Just in case any time travelers were out there and wanted to attend.
So, did anyone show up?
Nobody showed up to the party, unfortunately. The video also talks about the Moberly-Jourdain incident, where these two women claim to have traveled back to 18th century Versailles.
Wow.
And then there's the chronovisor, this rumored Vatican device for viewing past events.
I love those kinds of stories.
Yeah, they're fascinating.
They remind us that our fascination with time travel goes beyond the science.
Right.
It taps into this deep desire
to explore the unknown.
Yeah.
Push the boundaries of what we think is possible.
I agree.
Yeah. And who knows, maybe some of those stories hold a grain of truth that we haven't uncovered yet.
Yeah.
But let's shift our focus to a slightly more playful question that Unveiled brought up.
Yeah.
What if UFO sightings are actually future humans visiting us in time machines.
That's an interesting one.
Yeah. What do you think about that idea?
It's a wild idea.
Yeah.
But intriguing nonetheless.
Why would future humans want to visit our time?
Well, the video suggests that they might be curious about their origins.
Okay.
Imagine being born on a space colony orbiting Mars.
Yeah.
Or some distant star system.
Right.
Wouldn't you be fascinated to visit Earth?
Yeah.
The cradle of humanity?
That makes sense.
Yeah.
It's like going on a historical pilgrimage to connect with your roots.
Right.
But why all the secrecy? If they have the technology for time travel, wouldn't they just introduce themselves and share their knowledge with us?
Perhaps they're concerned about disrupting the timeline.
Okay.
Or revealing themselves. Before humanity is for such advanced knowledge.
It's almost like they're following a temporal version of Star Trek's Prime Directive.
Exactly.
Trying to avoid interfering with the past.
Yeah.
But let's be honest, if time travel were possible, wouldn't you be tempted to peek into the future?
Absolutely.
Yeah.
Who wouldn't want a glimpse of what lies ahead for humanity?
Exactly. But speaking of the future, let's consider a truly mind-boggling concept. The end of time itself. Unveiled. Briefly touches on this, exploring various theories about how the universe might eventually meet its demise.
Okay. That's getting pretty deep.
I know.
What kind of scenarios are we talking about here?
Yeah.
Well, one possibility is the big freeze.
The big freeze.
Yeah, where the universe continues to expand and cool down until all activity ceases.
So it's like a slow cosmic fade to black.
Yeah, a very slow one.
Okay, what else?
Well, then there's the big crunch.
The big crunch.
Where the expansion reverses.
Okay.
And the universe collapses back in on itself.
Oh, wow.
In a sort of reverse Big Bang.
And we can't forget about the big rip.
Oh, yes, the big rip.
Where the expansion of the universe accelerates so rapidly that everything, even atoms themselves, gets ripped apart.
Yeah, those are all pretty intense scenarios.
Yeah, those all sound pretty intense. What happens to time in those scenarios?
That's a question that still has physicists scratching their heads.
Yeah.
But it's safe to say that time as we know it would cease to exist.
Okay.
The very fabric of space-time would be fundamentally altered.
So we're talking about a complete and utter end.
It seems that.
To everything. No more space, no more time.
Right.
No more existence.
That's the prevailing theory, at least for now.
Yeah.
It is a very difficult concept to grasp.
Yeah.
But, you know, it serves as a reminder that even the universe itself is not eternal.
Yeah, it's making me think about things from a whole new perspective.
I know, right?
If time has an end, what does that mean for our lives?
Yeah.
And our choices?
That is a question philosophers have been pondering for centuries.
Yeah.
But perhaps the most important takeaway is that, you know, the finite nature of time makes our actions and experiences even more precious.
I like that perspective.
Yeah.
It's a reminder to make the most of the time we have, however long or short it may be.
Exactly.
But before we get too philosophical, I have to ask, are there any theories out there that offer a glimmer of hope beyond the end of time?
What?
Could there be a new beginning?
Yeah.
A rebirth of the universe?
That's a great question.
Yeah.
Some theories, like the Big Bounce, propose that the end of one universe could be the beginning of another.
Okay.
Imagine a cyclical process of expansion and contraction, with each cycle giving rise to a new universe.
So even if our universe eventually succumbs to the end of time, there's a chance that something new and amazing could emerge from the ashes.
Potentially. Yeah.
That's a hopeful thought.
It is. And who knows, maybe in one of those future universes, time travel will be as commonplace as taking a train.
That would be awesome. This deep dive has really stretched my brain.
I know, right?
We've gone over so many fascinating concepts, from the relative nature of time to the mind-bending possibilities of quantum phenomena like entanglement and tunneling and those delayed choice experiments.
Yeah, those are pretty crazy.
And we even touched on the possibility of time travel through things like closed time-like curves and wormholes.
Yeah.
And then not to mention parallel universes.
So many possibilities.
It's been quite a journey.
It has.
What's truly remarkable is we're not just talking about science fiction.
Right.
These are real scientific research and theoretical frameworks.
Yeah.
And quantum physics in particular has opened up so many avenues that were unimaginable just a few decades ago.
Absolutely.
It's incredible to think about how much we still don't know about the universe and the nature of time itself.
Yeah.
But it's also exciting.
Yeah, for sure.
What stands out to you as the most significant takeaway from all of this?
For me, it's the realization that everything is interconnected.
Okay.
We tend to think of time as this linear progression with, past, present, and future neatly separated.
Right.
But quantum physics suggests that it's far more intricate than that. The act of observing, the decisions we make, even the very fabric of space-time, it's all part of this complex cosmic dance.
I love that analogy.
Yeah.
A cosmic dance where the rules are constantly shifting and evolving.
Exactly.
It's both exhilarating and a little bit daunting, wouldn't you say?
It certainly is. I mean, the universe is far more complex and mysterious than we can fully comprehend.
Right.
But, that's what makes exploring these ideas so captivating.
Yeah.
There's always something new to learn and wonder about.
The book Time Travel, Religion, and Simulation Theory asks this question that I've been pondering throughout this whole deep dive.
Yeah.
Is it possible that we're actually living in a simulation?
That's a great question.
Could all of this be an elaborate computer program created by some advanced civilization?
It's a question that's been gaining a lot of attention lately.
Yeah.
Especially with advancements in virtual reality and artificial intelligence. If we can create increasingly realistic simulations, is it so far-fetched to imagine that we ourselves might be living in one?
It's like a cosmic version of the Matrix.
Right?
If that were true, would it change anything about how we live our lives?
That's a profound question.
Yeah.
If we are in a simulation, it would certainly challenge our understanding of free will and the nature of reality.
Right.
But it might also offer a sense of comfort.
Okay.
Knowing that there's a higher order at play.
I guess it depends on whether the simulators are benevolent or malevolent.
Exactly.
But regardless of whether we're in a simulation or not, the fact that we can even contemplate these questions shows the power of human curiosity and imagination.
Absolutely. Our drive to explore and understand the universe is one of the most remarkable things about being human.
And who knows what incredible discoveries await us in the future.
Right.
Perhaps one day we'll unlock the secrets of time travel, or even create our own simulated realities.
That would be amazing.
I, for one, am excited to see where this journey of discovery takes us.
Yeah, me too.
This deep dive has left me with a sense of awe and wonder and a renewed appreciation for the vastness and complexity of the universe.
It is truly amazing.
I'm definitely going to keep exploring these ideas and see where they lead.
That's the spirit. Keep asking questions.
Yeah.
Keep exploring. Never stop wondering about the mysteries of the universe.
And to all of you listening out there, thank you for joining us on this deep dive into the mind-bending world of quantum physics and time travel.
It's been a pleasure.
The most exciting aspect of this journey isn't necessarily finding all the answers, but rather embracing the questions and letting your curiosity guide you.
Exactly.
So keep exploring. And who knows? Maybe you'll be the one to unlock the secrets of time itself.